Ja, is oké. Nice. Yippee. Holy shit. I don't know. I didn't read books. Well, apart from a collapse. Could collapse this. But it is okay. And then we just add zeros to it. Subtract 1. And divide by 3. It goes wrong again here. Yep, looks like, well, it kind of works. Maybe I do want to collapse this though. Although the chance for it, wait, it says not collapsible, this one. Although it, yeah, it doesn't even matter. If I collapse this, it will expand at the next step anyway. Because you have to borrow from it. I think the only thing that would be important is to keep one fixed in between. So if maybe two fixed things are one after another, I should turn it into a single one. But yeah, no. Let's add an assert for that, so that I'm alerted when that happens. That would be KClass print on. Still learning. Yeah, well, I think I already did, right? I mean, I've been documenting it out loud, but people keep leaving, and then or maybe new people come in. Usually I'm enthusiastic about a project until I stop with it. So if I stop with this, and hopefully I should stop very quickly, because I have to continue with my real project. Then I won't have the time to write up all the documentation again. Yeah, well, that's down the road. Yeah, it's kind of weird though. What was it printed before? Expanding 0. Expand this one? Not convinced. Actually, it does go wrong before anything interesting happens. Damn, what the hell? Oh, right. Yep. Yeah, of course. I'm printing out an expanded pattern and then catenating it. And maybe at that point I should catenate fixed things. So I could do a cleanup afterwards. I'm not sure. Isn't it in the description, Carl? I put something in the description of the video, of the stream. Well, I will be telling as soon as I get more output. I have to get the function working. Well, this is appending stuff, but not exactly in the right way, because save and patterns is empty. I don't even know that is probably possible. Yeah, I just had that, but I deleted it again. Yeah, it's not about intelligence, no. If you promise to hang around for the next half an hour at least, then I'll explain again for the umpteenth time what I'm doing. I'm just getting tired to explain things and then see that all the views rotated while I was explaining. If I'm just coding and not saying anything, it seems that people hang around longer than when I try to explain what I'm doing. Anyway, I don't have my append yet, I think. No append. Pattern named append. Okay, so I have the bits add up and the pattern must be added. Okay, and pattern is a number. I don't know, I don't have an OR operator, do I? Or a plus operator? I don't know which operator I have. Maybe none. Now, let's see if this works. Let's see if I have an operator plus in number. Yep, I have this. That worked. Okay, I'll explain it. The people still there? Yeah, yes, no, yes. K0 are all the numbers, all the positive numbers that end in 1 in 0 steps. So that would be only 1. If you don't do any step at all, then well, you don't do anything, and it must be already be 1, right? K1 are all the numbers that become 1 after a single step. And a single step means, as you know the Collatz conjecture, I hope at least, multiply by 3, add 1, and then divide all the 2's away. And this means 0, 1 repeated 1 or more time. And so this is, for example, 0, 1, 0, 1. That's the smallest number. Or it is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and so on. And each of these numbers belong to K1. Each of these numbers end in 1 after a single step. Don't believe me? That times 3 is yep, and then plus 1 is and then divide all the 2's away, divide by 2 until you can no longer divide is 1. So any repeated O1s is element of K1. Now we're going to calculate K2, and the way I do that is by multiplying by some power of 4, subtracting 1 and dividing by 3, so that if you go the other way, I multiply by 3 and I add 1 and divide all the factor of 2 away, that we get, you know, there. So it's back and forward. So we begin with this, and I have to expand it because I need to divide it by 3 in the end. And dividing by 3 requires that that all the repeating patterns can be divided by 3, which means that a modulo 3 must be 0, and a modulo of 1 is modulo 3 of 1 is 1, so it's not 0. Therefore, I have to expand it into a series of well, it repeats, you know, it's 0, 1, or 0, 0, 0, 1, 0, 1, or 0, 1, 0, 1, 0, 1, and only when I repeat it at least 3 times every time, the modulo is 0. So I expand it, repeat the 0, 1, the pattern here between the square, the pattern between the angle brackets is repeated 3 times, which by the way is 21. So 1, 2, 4, 8, 16. So 1 plus 4 is 5, plus 16 is 21. 21 divided by 3 is 7. It's divisible by 3. 21 modulo 3 is 0. And now I have to append one more 0, 1, because angle brackets means repeated at least once. So this is 1, 0, 1, or 4, or 7, etc. This is 2 0 1s, or 5, or 8, etc. This is 3 0 1s, or 6, etc. And then you have all of them starting at 1. So this group together equals that thing there. And what I'm doing is the first one, so we begin with this thing, expanded. Well, it's just 1, so it doesn't get expanded. And that comes behind the other one. So each of these 3 get this behind it. And the 0 is as well. Apparently you have an empty 0, empty digit. So now you get the same thing as before, but then with an extra 0, 1 behind it. So for example, this one, still here, but there is a 0, 1 after it. And this one is still here, but there is a 0, 1 after it, etc. Yep. So lots of debug output, but the expand goes from here, we're expanding this, we get that, a 3-fold. Next I'm multiplying with some factor of 4, why 4 and not 2, because we're going to divide all the 2's away. Because multiplying by 4 does not change the modulo 3. If the modulo 3 is something and you multiply by 4, then it's still the same value. Now, well, multiplying with some power of 4 means a repeated number of double zeros behind it. 2 zeros means you multiplied it by 4. Repeated twice is 4 zeros, means you multiplied it by 4 squared, and so on. So this repeated double zeros, at least once, is that 4 to the power n, where n is larger than 0, and it's added to all of them. So now we did this, and then I subtract 1. Well, we have a whole series of zeros, and you subtract 1 binary, then you get a whole series of 1s, and a borrow. So this 1, turned into 0. And the repeated zeros turned into repeated ones. Same happens here. This borrow here is gone. And the repeated zeros have become repeated ones. And again here, this one is gone and the repeated zeros are repeated ones. So now we have subtracted 1. Next, I want to divide it by 3. Now this, because I repeated it 3 times, is divisible by 3. And well, 21 divided by 3 is 7. So now it is repeated 0, 0, 0, 1, 1, 1. And this is 4. Yeah, that's not divisible by 3. My code currently does not handle it well. It just rounds it off. So I get 1. The rest is not handled. It has a rest of 1. That's the modulo 3. It's the rest that you get when you divide. It's not handled. The 3 can be divided by 3 and that gives 1. Now the same here, 21 turns into 7. This is 20. 20 divided by 3 to round it down is, is that correct? 18, yeah. 18 divided by 3, 6. And 3 divided by 3 is that. But also here we lose the rest after division of the fixed part. This is the only one that is correct, because the 0, 0 could be divided by 3 cleanly. So this is actually a member of K2, but the rest went wrong. So I have to fix my divide by 3. And when I have done that, and we get a K2 that is correct, and I think that after that it just works, because that is a recursive formula now, and I imagine that then K3 will be correct as well, and so on. Note that once it is correct, this is no longer an approximation. This is all the numbers all the way up till infinity that reach 1 in 2 steps. I leave nothing away. It's 100% complete. Just like this is already 100% complete. Absolutely every value is represented here. It doesn't prove anything, but my hope is that if I generate enough of those, that I will start a pattern in the patterns, as it were. And that's probably not going to happen, because otherwise it would be easy to prove, and others would already have proven it. But it just can't help myself to try to fix at least this class, and so I get these patterns. Okay, so up to division. Dividing by 3 means that, well, it's actually already doing it correctly. And what I get then is the rest. I already get the modulo value of each pattern. And I just have to remember that for the next pattern. So then the next pattern can be divided by 3, like we did. And then I have to add the rest. The rest being the rest divided by 3, which is 0, 1, 0, 1, 0, 1, 0, 1. Or 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Yeah, or 0, 0, 0, 0, 0, if the modulo was 0. In this case, and this 1 came from the 4, so that is a modulo is 1. So we have to add 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1 repeated. So this turns into 1, 0. And then that should be correct. Now I think that, I mean, if I add 0, 0 repeated, then the 0, 1 stays 0, 1. If I add 0, 1 repeated, then it becomes 1, 0 repeated. And if I add 1, 0 repeated, then it becomes 1, 1 repeated. But not quite, because it extends also beyond it. I mean, this is a variable repetition, but not an infinite repetition, while the modulo rest is an infinite repetition. So the only thing I can say for sure is that if we have any rest, well, what I can say is that if we have any rest left here, then it was not divisible by 3. So we then throw it away. It should not be in the result. But since this is not an infinite repeat, but just a finite repeat, I'm slightly confused how to continue. Maybe I should expand this anyway. That would blow up things even more dramatically. Because in base 10 is just randomness, pure randomness. You could use base 3 or base 2, because it's all modulo 2 or modulo 3 stuff. Maybe I should print it both in binary and in base 3. Any other base makes no sense. You'll not see any pattern. Well, if you use hexadecimal, and you would still see certain patterns, of course, that you can also see in binary and so on, but binary by far shows the best patterns. I mean, take this. That's K1. Try that in decimal 10, in base 10. It's not possible. It's not possible. So the base 2 is mostly to make this easy, and that is very important because this is variable and can be many values. So I really need this. I really need a repeat of some binary value. You could argue, well, then do it base 4. Maybe that would also work. Probably would work, yeah. Base 4 is maybe even better. Now I think about it, because all those repeats must be at least 2 bytes. Because multiplying by 4 at least keeps the modulo 3 the same, so that's kind of important. What is 21 in base 4? I guess just 1, 1, 1, right? So you get 1, 1, 1, 1, 1, and 0. Oh, that's not bad at all. Yeah, here too. Same time here. Yeah, I should go back to Vulkan very soon, because this is going to be a dead end anyway. I already didn't want to do anything today, but couldn't help myself. Do I want to finish it? Division by 3, how do I fix that? Yeah, after subtracting 1, of course, the modulo must be 0. And then it's kind of problematic. I'm forgetting to do something here. That's what I'm forgetting. I have to add an extra 0. I can add it in front of it. I have to add an extra 0 here if the modulo is 2. So I need to be able to calculate the modulo of a whole pattern. Even for this one then. Yep, modulo must be 1, and then I can I must, if the modulo is 0, I have to throw it away, so this can be thrown away, very simple. If the modulo is 1, this is modulo 1, then I leave it. And if the modulo is 2, like this one, I have to append 1 0. And then I can continue with this step. The result then will be that the modulo of the 2 left over terms will still be 1, and then after subtraction the modulo will be 0, and then it can simply be divided. I don't have to worry about it. Okay, I need to write. I need to continue with writing or having a function that calculates modulo 3 of my expanded patterns. So whatever I print here. That is KS plus 1 list. It's a return of expand. Expand should take care of that, I think. So that are KClasses. And KClass itself already has a modulo 3. I have to assume that that works, right? So yeah, let's test it out by value for the moment. So printing, no, this should work. I mean, the modulo is calculated. See how I calculate the modulo of KClass. What is this? Why can I not find it? This is KClass. There's the modulo 3. It's not implemented. Damn it, not implemented. Divide by 3 is implemented, but in a stupid way. Yeah. Okay, well, let's try to implement the modulo quickly, I guess. It will be a const thing. I should rename this function, I think, to value. This is confusing. Not planning anything. Yeah, not for, I don't know, not for midnight, but could be 2 a.m. Because it's, I don't know, I don't fall asleep early anyway. Although I guess I should get up earlier and therefore go to bed earlier. So the idea is I have some pattern here, probably a multiple of 3 long. Now maybe one that is not a multiple of 3 long, and then maybe one that is not a multiple of 3 long, but divisible by 3. So we start at the beginning, and the beginning here is at the end, and that would be this one, and it is not fixed, but the modulo equals 3. Sorry, modulo 3 equals 0. It is 3. To the modulo 3, 0. So m becomes 0. And then I do something with m, and I think I just added to m3 then, or maybe I do something with it while I'm adding it, but in the end I'll add it to m3. Also keeping track of the number of bits. I suppose I can do that totally at the end. So in this case m3 it was 0 and gets added 0. And then we go to the next one. And that is damned also dividable by, I don't want that. Let's make it a little bit different, right? Not dividable by 3. That is 11, if I'm not incorrect. So now we get it is fixed, yes. So we go to the next one, and now the modulo of 11, modulo 11 modulo 3 equals 2. And then we add 2 to M3. And the length now becomes 2 plus... I really don't want to add a 2 there. Now all repeated patterns must have an even number of bits. So it is kind of nonsensical to add it. I think let's just add the fixed length. Not that it matters actually, but well, fixed. Keeping track of the fixed length. It's okay, so fixed length becomes 4 because we encountered this one. And then, yeah, we skip the next one because that's not fixed. And the modulo is 0. So then the result is that we return 2. Which is correct. But now let's assume that we have another one that is fixed. Say 5 in front of that, and in front of that we have another repeat. Then I'm going to get at this one and calculate the modulo, which is 2, and then I still have to do something with my fixed length. What I have to do with my fixed length is, depending on whether the fixed length is odd or even, I have to invert M. So let's do fixed length percentage 2 equals 0. That means that we have an even number, then the modulo does not change, so I can just add M. And otherwise we invert it. I think this calculates the modulo of my whole bit pattern. Right, let's try this out, as in nobody knows where the code was. Maybe here. No, in Expand. They are similar, but not like the same, right? I mean, I don't think I could understand Afrikaans. And their grammar is absolute horror in my ears. Right, yeah, what was I doing? If an I have to do this. I'm building on a list here. There's a running over list and an assign to list. What the hell? Oh no, that's after I'm done. So it's like previous list and then do stuff with it and then let's write it over that, yeah. Yeah, I cannot do that up front. I'll have to do it afterwards, I guess. Let's make a second copy. Yep, so drop out modulo zeros. On 1 can be added as is. And when it is 2, I want to append a 0 to the end. I don't know if that works. Probably not. Nope, that doesn't work. There must be a smart way to do this. I guess that worked. So we went from here, which has a modulo 1, to here, which was left alone, except for the expansion here. So that thing plus 0. And then we also went to, I guess, this one, which is a modulo of modulo of 2. So what is now wrong? No, I think it was this one then. This one with 0, 1 added to it has a modulo of 2, and therefore also a 0 was added. Well, this one with a modulo, sorry, this one with 0, 1 added has a modulo of 0, and therefore it was removed. So this is now the expanded version of that, where every element has a modulo of 1. And then multiply it by power of 4, subtract 1, and now we can divide it by 3. See, this is now 9. So now we can cleanly divide everything by 3. No, that looks good. Have a quick test with GDB. So I print 0b. Let's say we repeat this, I don't know, twice. And that there, and this a few times. And get that number. And if we multiply this number times 3, and then add 1, I get that number, and then we have to divide this, or let's print it as a hexadecimal value. To remove a few zeros from that, that means divided by print this number divided by 64, I believe. Nope. What did I do wrong? Maybe one more. Yep. And then this number times 3 plus 1 should be power of 2. And it is. So that's correct. This is indeed an element of K2. So it seems to have worked. Cannot imagine that I have already finished now. I wish there was a better way or a more robust way to check that these values are correct. Yeah, let's just test it by hand. Okay, that's easiest, I think. So only 2 of them. So we have this. I have to check both of them. Let's begin with this one. So I see already one thing that's wrong. I think 3 is also 3 is an element of K2, and the smallest value that I see here is with 0, 1 appended. But okay, let's see. Apart from that, that would mean that I could append it like a square brackets, maybe. That would work. I think the right answer is going to be this. Let's check this one anyway then. So I have to multiply this by 3. That becomes 7 times 3 is 21. And this multiplied by 3 is 9. And this is 3. And then I add 1, so this becomes 0, replace 1, 0. And then divide all the zeros away. And yeah, that's repeated 0, 1, so that is a member of K1. So that one was correct. And this one, and also 0, 1, 0, 1, 0, 1. And this becomes of that, and then add 1. And then divide all the zeros away. Yeah, and then again we have a repeated 0, 1, so it's correct. It's just correct, but not this repeat here. This repeat is correct. 0 is not the solution. So you must have at least 1, 0, 1, and then you have 1, which is also not the solution. So this one must. But wait, if this is repeated once, at least, then this again can be square brackets. So that would mean that 7 times 4 is the smallest value that comes out of this. I don't know. Anyway, let's try to produce it with the square brackets. I have a multiply with the minimum power of 4, then must become 0 instead of 1. So this might be 0, maybe, I don't know. Actually, I think it depends on whether I append that as 0 or not, but I'm not sure. No, it's the same thing, but with square brackets, so guess that worked. So 3 is the smallest value here. And this has angle brackets, so you have also a large value. So that is 7 times 4. 28. Wait, that's not correct. That's an even number. Cannot be an even number. Okay. The borrow didn't go well. The borrow did not go well. I have just a single 0, 1 here that survives. Because the modulo is 1. Yeah, we cannot have that. Seems like in theory it's okay, but not if the fixed number is an even number. Then the repeat must be at least once. You're always going to have 0, 1 here repeated. So it simply depends on the value of the fixed number before that. And this thing is being added as a 0, 0. So already at this point I can see it. And then it's the other way around, I guess. If this is a 1, it must be, yeah. Let's do that. Let's do that. So the minimum power depends on whether the least significant pattern is odd or even. Something 0 or 1. The something being, let's put that around it just for slightly better reading. So if I can say what a power of 0 is, and when it must be, wait, what was it? If it is odd, then it must be repeated at least once. So it's like this, right? Something. If it is even, then the minimum power is 0. That is, it becomes odd. So it should work, I think. And otherwise, well, we have one more chance. is here? Is old. Because there are infinitely numbers of to be checked postbinding. If you check 100, it doesn't say anything. Plus they check the first 2 to the power 68 numbers. But that's not enough. There could still be a much larger number for which it doesn't hold. Without proof, that's just fact. I think if I would actually write a proof that a conjecture holds, I will be less famous than when I would prove that there is a number of 396 digits that I can print. That is a counterproof. Then people would be upset that the conjecture is not true. But unfortunately, I don't think such a number exists. It's probably true. Anyway, well, Postbunny, you're a mom, so you can always say it's true because I say so. Isn't that what mothers always say to their young children? No, it's 68. It shows that you are not remembering numbers as numbers, but visually. Confusing the 8 and the 6. I remember the 68 as being 4 more than 64. So there's no way that it was 86. Yeah, okay, so I have to add an is or to something, and I don't even know what. KClass. Why didn't you say so? KClass is odd. That's a pattern, I guess. Values back is a pattern. And then I can go to do the number by calling value. And now we have a number, and now I must know if the number is even or not. And well, we just don't know. Suppose I have to add it here. Is odd. This is odd if the least significant bit is odd. If it is empty at 0, that's not odd. Yeah. That didn't work. It's exactly the other way around or whatever. No, this is odd. This is even, so it should be like this. And this one is odd. But it didn't change. I guess my is odd does not work. That's highly annoying. Oh, that must be 0. Oh, this must be 0. Again or nothing. So that's the reason then that this returns. Why would it say nothing, empty, when I call it on this? Wait, I'm printing these things and they're not in reversed order. So is this the front of the back on this side? Until you know that I really don't know now at this moment in which order the KClass deque is ordered. Oh. I reverse these two. Prefix append, that also is pretty important, I guess. I'm gonna go with the multiply with power of 4. And place front. My God, the front is on the right, and the back is on the left. Place front, so yeah, so go. 0 being the least significant, front least significant is on the right, so that makes sense. Now let's see, we multiply by 2 also works on the front. Print prints it in reverse. So it begins at the end and ends with the front, so that's good. Still consistent. The Modulo 3 begins at the front, so on the right, to the least significant. From least significant to most significant, that's correct. And still not. What the hell is going on now? Still calling it on nothing, which is annoying. I don't understand these lines, but this one is definitely wrong. That's totally odd. It doesn't work at all. First time we get here, and that is correct. Continue. Second time we get here, that's wrong. Okay, then from the beginning, continue. So now it would go wrong. It says back here. Well, this should be front, I suppose. I thought I just changed one of these things. Then which back and front did I change before that? I'll never know, I guess, until I run into a bug again. Well, good. I should have had a list of K2 as well, I suppose. I can generate one and then see if all the values are there. I have K2. That should help. So this one is that one. 1, 1 and 0, 1 repeated twice. But this thing isn't even repeating, isn't even generating 3. The program is wrong. Okay, well, and the next step is then 3 zeros. So this one. Oh, it's even better than what this thing has. I suppose 3 zeros and 2 ones, or 2 zeros. Yep, that's just good. Let's have a look at K3. Yeah, that's the old program. So I guess that K2 is okay. Now we begin with the first one, and that gets expanded into this. So it's repeated 1, 2, 3 times, and plus 1 time. Oh, that's just this. My 0, 1 is no longer there. Yeah, it's like this. Yeah, okay, class expand on the first one. Okay, and this is K2. First element of K2 is going to be expanded. So we're calling expand on this, which is the first element. And that calls then expand on 0, 0, 1, which is a repeat of 0 or 1 or 2, that's correct. And then expanding this, which is just fixed, so that just stays whatever it was, but we lose 3 zeros. Maybe I just don't print them. I guess I don't print them. And then we have here 3 zeros and 3 1s, so there's that one. Expanded. No, same thing. That just works. And then we call multiply by 2, and then it says meh. I guess that went wrong on this pattern then. And I want to multiply this by 2 because otherwise it becomes even. Yeah, that's correct. Interesting. No, I should not try to multiply this by 2 because the modulo is 0. So something is wrong. Something is going weird. A dot out. Running up. Calling multiply by 2 on pattern 0. Which contains, yes, it's 6 bits, 0 or more repeated, 21 in it. 21 in it? Where the hell is the 21 coming from? Okay, so this is it's a big thing anyway. Let me see. So the least significant thing is up front, which is this, which is 21. Yeah, 6 bits. And then we have a fixed type with this value, which is hexadecimal this one value of 17 bits. So I have here 330001. I'm an idiot. It says 3, that's 2 ones. And then 1231. And then C, which is 1100, isn't it? And C is 12, yeah. And then 7. And then in total 17 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, if you say so. And these are 18 bits comprised of 7, 1, 2, 3, 1, 2, 3, 1, 1, 1, 0, 0, 0, 1, 2, 3. Is that correct? This is a 7, then a C, then a 1, and then a 7, and in total 18 bits. So that is 3 times, there must be 3 zeros in front of it. Damn, 6 bits. And we called modulo 3 on that. And in my opinion, that should have returned the modulo of this value, which is, oh, what is just this value? Percentage 3. That's 2. So that is correct. Yeah, and then I'm calling multiply 2 on this. What nonsense. I should call it on this. And we should do this before the pushback. Depending on here. What is, no, we should not. What? Multiply by 2. Still learning. Yeah, that's a good question. I don't know. A couple, not that many. What's going wrong here? Doesn't seem to make any sense whatsoever, I would say. I don't know. It's 573. Vector of KClass not defined yet. Wow. think I'm concatenating the fixed things in the wrong order. At the very least. Let's fix that first. Mark post, well then you can see the patterns, which you definitely do not see in say decimal. Let's see, if it is empty or that is unequal fixed, oh no, these are both fixed, then we are here. And I do back append patterns front. And then append the rest. So append means on the left, right. I mean, correct. So this is wrong too. Ah, now I'm so confused. Really need to find this double KClass constructor. It's probably in an empty place back somewhere. This one, I guess. It is the list plus expanded next pattern. Yeah. Mm-hmm. Getting crazy. So I have prefix. I want to print it like this, and then append. And that means that this is the end. Or the back rather. And this is the front. And I begin with copying append to patterns. So I already have this. And then I must append prefix to append. It's the naming is brilliant, yeah. Especially because this is the front. The front gets appended. It's confusing. Anyway, in the most simplest case, I just want to add it. So we get now in patterns, which is already append at the front. And I just insert at the end of that the prefix. So this is correct. And I want to do that if either of them is not fixed. Either being either prefix or append, and patterns contains append. So this is append, and the other one then has to be prefix. And they connect at yeah, no, double difficulty. They connect at the middle, but then which part is that of the patterns thing? I guess, oh, that's a whole list already. So that's the end of append, right? The end of append and the begin of prefix. To the back of patterns, which is append, connects to the front of prefix patterns, yeah. So this line seems correct. But I also want to do this when prefix is empty. Or do I? I mean, I think I want not to allow appending something that is empty. That doesn't seem to make sense. So patterns cannot be empty because patterns is already equal to append here. And then if prefix is empty, then well, we don't have to do anything actually. But might as well, yeah, well, no, and then we should not do anything. Let's make it so if patterns is not empty, that means that append is not empty. Wait, it doesn't make any sense. I must test prefix here. Prefix is empty, now we are already append, and therefore we're done. So that must be prefix dot patterns. Prefix empty, then we are done. Otherwise, we test if the probably better readable if I reverse these things. The prefix is on this side, it's as well here, and the front is on that side, so now we have the middle here. And the patterns then is, well, it's this thing on that side, it's the back. That is the case, then I want to append to patterns the thing that we didn't have yet, namely the prefix, which now is not empty. Yeah, so also here we have an the begin and end, that thing. So add from begin to end. It's all reversed. Else patterns back. So patterns back, that would be here. Append, and then append would be prefix actually. Append dot patterns, it's not correct, and it must be prefix now. Prefix front, yes, and then if prefix is larger than 1, then we must do the same thing as above, but then +1 at the rest. And this append now is actually a prepend, more or less. It's not really append, I think. I mean, we are appending to the append, so it is definitely a prefix, prepend. So in patterns we have this, and then I prepend the first thing to the front of the prefix. Yeah. That seems to make more sense. And then the back of patterns is a pattern. So the pattern append must be turned into a prepend. So the pattern that must be prepended, it is more significant, so that must be shifted by our number of bits. which is just m bits. Blah, blah, blah. And then we can add that. Okay. Whoops. So now hello. So my audio just broke in a very interesting way. Holy shit. Can you hear this? Oh my god. Testing. We're back. I think my yeah, my voice morpher turned off. Now everyone knows I'm alien. Damn it. No, I think my microphone was suddenly getting a helium hiccup. Yeah, I restarted this part of my audio. So what I was saying is that now finally we start on the right side. So this is on the left side, and that's what we start with. And the expansion is still correct. And then we do the thing in the middle, which is just printed wrong here, but it's just that. And then they expand on the last bit, which is also expanded correctly. And then it should be concatenated correctly, as in concatenate this pattern with this pattern, right? Yes, and then with this pattern. So the first one of this with the only one of this, and then the first one of that. And now you see it is done correctly, because before these two were swapped, I had 3 zeros and 2 ones and followed by that. But now it's really now it's correct. And this is yeah, that one, and then we get the same thing followed by that one, which is the second one here, and then we get the same thing followed by last one. Yep, correct. And then we get this thing followed by okay, that's this one. Two of them. Followed by no, still two of them. That's up till there. So I should just highlight this. All of it. No, and then again with that, and then with the first one from here, and then the second one, and last one, and then finally we have just that, and that, and that, and that. Okay, now that looks finally good, but then the pruning still crashes. Shouldn't it be pattern multiply by 2? Yeah, I need to know what it is doing here more accurately. How many of these functions do I have? This is pattern. The whole problem is, of course, that it is doing it on back. Yeah, back of result is that, so that's KClass. Multiply 2 KClass as this one. Now we're doing multiplying that on M pattern 0. Because that is not correct then, but well, I don't know. Entering this. I think that what needs to happen is you just put a 0 in front of it here. That's what should have happened. You really just have to multiply the whole thing by 0. Nothing you can do about it. Except that if I do that, I might as well shift the repeat on. In other words, add a 0 here and then reverse all these bits. But yeah, then it becomes even. So there, could do that. No, I could not do that. It's nonsense. That is nonsense. Okay, so I just have to add append a 0 at the end. Which means that if it is not fixed, I just have to add something. KClass and patterns return is what? So deque of pattern, so then I have a pattern, I can just ask for the type. Okay, type equals fixed. Then I do what I did, and otherwise I have to insert something at the front. So in patterns, in place, front. And then it would be the arguments are the constructor of a pattern, and that is a number bits fixed by default, number bits type, and the number is 0, the bits is 1, and the type is fixed. So it's the same as multiplying by 2 then. Right, I think that now we had, where's my pruning? So we have pruning, and now we see calling multiply class multiply by 2 of that, and I do not crash anymore. And the result is then that seems that this one was removed. So that would be removed if this is the modulo of this thing is 1. Well, I believe it. Or not. The modulo of this thing, what is it? The repeat does not matter, so I can just test this plus 0 on, then see what the modulo is. That is 0, yeah. So this is thrown out because the modulo 3 is 0. This one was kept. Yeah, here. And multiplied by a power of 4. So 0, 0 is added. And then I guess that this one was kept as well, because the modulos usually add 1 every time. Yes, so this one's kept as well, but multiplied by 2. And then multiplied by a power of 4. And that multiplication by 2 is necessary to make this a modulo of 1. So adding a 0 to that should make it the modulo 3 must be 1. Yes. And then the next one is removed, I suppose. My God, this thing is long already. It was not removed. Okay, let's test this. followed by 0, 1. That's 2. Copy this from here, right? So that also was multiplied by 2 and then etc. Okay, we can go on like that, I guess. So now we do this one. That was removed. So you have add 0, 1 to it, and the modulo becomes 0, 0, 1, 0, 1. Print binary of this with 0, 1, 0, 1. Modulo 3. That is 0. That's why it was removed. So now we got this one, which was kept, I guess, exactly as it is. Oh, no. Wait, is expand. I have to look here. That was kept and then just multiplied with the modulo 4. So the modulo is already 1 of this one. So the modulo of this must be 1. And it is. I guess it just worked. It just works. Now, I'm gonna do all of them though. That one is, I think, I don't know what has happened here with this one. Is that this one? Seems so. Also has a modulo of 1. Can do that from my head. 1, 1, 0, 1. That is 13. 13 modulo 3 is 1, yes. And then this one. That must be modulo 2. Okay, so 1, 1, 0, 1, 0, 1. It is, I don't know, it's difficult, man. 3 times 16, 48. So it's 53 in total. Yeah, 53 modulo 3 is 50 modulo 3 is man, why is it so difficult? 50 modulo 3. Oh, that's 20 modulo 3. That's 2. Yep, that's correct. And that was thrown away. So yeah, 3 modulo 3 is 0. Well, this is correct. But then it crashed. Subtract 1 once or more, it will have a pattern here of 0 or more. But it doesn't matter whatsoever if you ask me. I can just change this into a 1 and borrow from the next. I think the assert is wrong. Let's change it. Oops. Oh, wait, like that. Okay, so If that is the case, then the type becomes 0 or more. This is pattern subtract 1. Okay, so now type is 0 or more. I can only subtract 1 from that. I agree, more or less, actually. I can only subtract 1 of that when it is 0. So I can pass the borrow all the way past the pattern that might not exist. So then we have to do an assert that the thing is 0. How do I do that? Well, in pattern, the thing is still called mPattern. mPattern. And I have an mPatterns. Highly annoying. Probably just should manually do this. Or I can just go from here till yeah, let's do that. I think all of these is just pattern, and then we go way down. More patterns. I should change the color of my selection because it's not readable. Substitute m pattern with m value. What was I changing? Oh, that. Yeah, the pattern. It must be 0. Pattern has a value. Oh, but if value is 0, then we already did something. Value is 0. Value is 1. Shift a bit, subtract 1, return true. That is correct. So my assert was correct. But it was 0. Now I'm confused. Okay, so an assert false now. It seems not possible. All of them end on the zeros. 0, 0, 0, 0. Oh, here's a repeat followed by a repeat. That is the problem. Yeah, that is the problem. And that is the only one. So you can set these to 1, 1, but then you have to subtract something from something that might not exist. Meaning that you cannot, I mean, if it doesn't exist, sorry, if there is no repeat, I have to subtract it from this. borrow the one from this one, and if there is a repeat, then I have to expand it with 1 and then subtract it from the, well, one of the repeats. I think we can already say that it is very prettily, very very quickly becoming very ugly. So I might as well stop now. This is not leading anywhere. Definitely a waste of time, this. Yeah. Yeah. Well, as expected, of course, but just too bad. Can I not get this last thing working? Is it even correct to have 2 repeats after another? So, now where exactly does this thing come from again? It's just a result of the prune where nothing was added. So this thing here. Expand of this thing, yeah. Yeah, yes. Yes. That's what happens here, yeah. I see it. This one is expanded till the modulo is such that this one does not need to be multiplied by 2 or has a half repeated 0 once outside of it. Therefore, it is just expanded to something with the modulo 0, and then we end on that, as in here. As a result, after multiplying with the power of 4, we have to extend it again. So this one splits up in 2 values, this one. Either for the repeat of 1 or the repeat of 0, for 1 or more or 0. And I guess I can already do that, because I know at this point, while pruning, that it ends on something that is repeated 0 or more times. So during the pruning, I can split it up. Now we would have fixed it. Yeah, why not? But it's gonna be ugly anyway. So before pushing back, I can test that if the modulo equals 1, so that we will not do anything after this. Is that correct? Yeah, it doesn't even matter. Doesn't matter. I have to borrow from it anyway. Doesn't matter. Nope. It just is not allowed ever to end on something that is repeating only once. Sorry, that can repeat 0 times. So this is about KC. ending with a pattern, or rather beginning with a pattern. This is the front. FM patterns. And patterns. Front. Pattern will be empty. Type. Zero or more. Yes, then I have to change that into ones or more, and just remove it completely. So there will be two of them, and otherwise I can add it. So I do that. Just copy it, change it. Okay, KClass. So let's first change it. It's not const anymore, so that should be possible, right? Set type to once or more, and then we push that back. The new K. And then again, but after I remove the front. So that would be like, is there a pop front here? Nobody knows. There's no pop front. It's more wrong here. Const pattern. Really? Patterns. I do have a set type, pretty sure of that, which is non-const, so front must be non-const. I guess patterns called on classes always const. Well, whatever. Oh, we do have a front. Well, let's see what that does now. What went wrong here? I no longer see the one that was a problem. What happened? This one was the problem. It's even highlighted. But it should print that also in pruning here. Pruning. Yeah, this one. should still be highlighted while calculating K3. And here I have while calculating K3, pruning, oh there it is. So I'm barely confused with something else, or yeah, this got way further. This thing got pruned into yep, either this or this. See, so this is repeated 0 or more times, and therefore I just split it up in once, one time or more, and just not having it at all. So these two combined are equal to this. And then the result is that after multiplying with a power of 2, we no longer have this following after thing that is repeated 0 times. Yep, so we can subtract 1 and we can do everything, divide it, and we got an answer. At least. I don't see K3 being printed yet, and then it starts over. What's happening here? Oh, we have to do it two expansions, I guess, right? This is expand of the first one, and we have 2 of them. So now it's going to expand that one, and that crashes. And that expansion looks like okay. While printing it, I somehow got 2 fixed patterns after another. And I wanted to combine all of those into one. So instead of crashing here, I'll just print it with a vertical bar in front of it, in between it. Now you can see which order it was. Already did that before. Now here we already see one. After dividing by 3, I get a 0 here. Where did that come from? So this one. Well, then again, this is already two fixed patterns after another. So where this is, did this one come from? That's after a -1. That's interesting. Oh, here. Yeah. You have this repeat and then had to multiply that by 2 for the modulo, multiply by a power of 4, and then after subtracting 1, this turns in all 1s. This turns also into a 1, and then we have to borrow 1 from here. And the only way to borrow it is to extend it to a 0 or more repeat, plus an actual repeat, and then borrow from that. So this turned into 0. And then at that moment you have two fixed patterns, one after another. So it is the borrowing the borrowing from a once or more pattern that can go wrong if we borrow from a fixed pattern. Yeah, okay. Can fix that too, I guess. K3 already has well, a lot of possibilities, and then it has well, at least all these patterns are the same. It begins with the same pattern and it ends with the same pattern. Well, that didn't work. Help. But in between, it's still a mess. What the hell is that, you know? And this, and here is one with a repeated pattern in the middle. It's also not to be very happy about. Okay, but whatever is repeated in the middle is at least also every time exactly the same thing. So we have something that is repeated 0 or more times, followed by some fixed pattern, possibly followed by another repeat, which at least is the same thing, followed by another fixed pattern, followed by a repeated pattern, and which is, for some mysterious reason, sometimes must be repeated once and sometimes can be repeated only 0 times. I don't think we have to fall over that. It's just the edge cases, and you know, the problem would be that if we change these angle brackets into square brackets, it would still work, but you would get an element that actually belongs in the previous K. So, and can be ignored if you ask me. So we could change everything into 0 or more patterns. For example, if you change this one into 0 or more, and then all the repeated patterns are put to 0, in this one too, and then this whole thing turns into 0, possibly. 0, 0, 0, 0. So that's obviously not a member of K3. And the same, even if you repeat this one at least once, then you get 1, which is element of K0, not of K3. That's why this must be repeated at least once, otherwise this doesn't make any sense. What is interesting, however, is the progression of these repeating patterns are very predictable. I think this is just always 1, followed by 7, followed by whatever this is. And if we do that one more time, and then we maybe have already enough information to look that up as a series on the integer number database. Do I really want to get rid of this concatenation? I think I want to. Just getting late though-ish. So the problem was borrowing from a borrowing from a pattern. And that pattern is always going to be once or more, otherwise we cannot even borrow from it, I think. Yes. Subtracting 1 works like this. I subtract from begin, aka front, aka the right side, aka the least significant pattern. 1, just from the pattern. If that requires a borrow, then it's going to call this lambda, passing a pattern, and then we insert a new pattern. Not sure when that is called anymore. No, it's not true. No, one that's maybe it's calling that lambda. It's more like what it returns. If it returns true, then we go to the next pos and then subtract 1 from that. So the problem is that if we do that, increment pos, and then pos points to a pattern that is a repeat, while the previous one was fixed, then we get to fixed patterns that must be concatenated. Oh, difficult. And what's with lambda? That just inserts before pos. So it might return a pattern that we have to insert before pos. And I think that is what it's doing when we try to borrow from a. If it is 0, if the value is 0, then I do make it all once and we return true. Yeah, so we make it all 1 and then we return true. Nothing, no problem there yet. But what if the next thing that we want to borrow from is a repeat? And of course it's going to be a repeat, unless this is a repeat. It kind of depends. Okay, so it depends basically, but I would already know that here. And then if it is not 0, well, we can just subtract it if it is fixed. And if it is once or more, then I can change it into 0 or more and insert one pattern. Now we are inserting value -1 already, because value was non-zero. Yeah. And then we are done also immediately. So if an insertion takes place, we're done. But at this point, I can already see if it needs to be merged, I think. Because I'm adding before, insert before. Yeah, that's our callback is always fixed. So if we are fixed, then we have a problem. Then it should not be inserted. Then we just should change our own pattern. Oh no. No. Something's wrong here. This is once or more already. Don't tell me this is hard. So example, you have a repeat, and we have a 0 value, and we have, say, another repeat, zeros. So that's the normal thing that would happen. Borrowing 1, then set pos, subtract 1, set pos to the point there. Pos is not end, and then we call subtract 1. And that changes this into this, obviously. Because it was 0, we do not insert anything. It's just callback is not called, it's a lambda. But it does return 1 because, well, yeah, it borrows. It needs to borrow. So now pos is incremented, and pos points to that. And then we call subtract 1 on that. So now it is also 0, it's also turned in all ones, and it is returning true. So then pos is set to this. And we call subtract 1 on that. That says, oh, but this is a once or more repeat. Therefore, I change this into 0 or more, and I insert this -1. But it inserts it as a new pattern. So now we have 2 fixed patterns on a row. And that happens at the moment that this insert is done. And then we would have to concatenate something. But there is another possibility. And I think that there is definitely a possibility that we have this repeat and then another repeat, like that. In this case, pos is this, subtract 1, return true, so pos is now pointing here, and then insert 1, change this and insert this value here, -1. And now we don't have to concatenate anything because this is just a crap pattern. Yeah. Inserts before pos. So pos points to this. Change it and we insert before. Before is on the right side. So I do not know anything anymore about this one. I could at most try to decrease pos. I guess I could do that because, yeah, why not? I know that if this is being called, it's going to return false. So pos is no longer required at that point. So we could do that, I suppose. Let's make this a multi-line lambda. It looks a bit ugly. That's better. So at this point I do actually not want to insert before pos if pos is not equal to begin and the element before pos is fixed, and pattern will also be fixed. Bit far-fetched everything, but hey, it's supposed to be fun, I guess. So we do if pos is unequal patterns begin, and the element before pos, I guess you can just dereference pos -1. Actually, that just gives another iterator, so I can do that. Now I have an iterator to a pattern, and I want to know if that is a fixed type, right? So if type equals fixed, then we should do something else than a simple insert before pos. So now we have the situation where pos is not pointing to the beginning and the one before that is fixed. And I think that is this situation. Although it already has square brackets. It's already changed into a 0 or more. But it doesn't matter much. And then we get this value we have in pattern. And I just want to combine it with with the 1 1 here. Sorry, I get this. This is the pattern that we get, and I want to combine it with the 1 1 that we have, which is pos minus 1. So let's begin with, we just go 1 back. Now we point to the 1 1, and then we have to change 1 1 appending this pattern. And that's really a prepend. Didn't I already have that, a prepend? Prepend on pattern, I mean. I'm not sure. Got the prepend. I have a prepend, but I'm not sure if it was on pattern or not. Yeah, this is prepending a pattern, and it is it's the pattern class. So that demands already that the type of both are fixed, and then we shift the pattern with our number of bits, and yeah, perfect. I think this should work. What? Pos is const. Yeah, how can you make the bloody pos? Wait, and patterns is it? Maybe it's a const thing. No, it's not. Or no, it's not. This is just a normal iterator. I think the lambda makes pos const. That was a trick. I thought the pos becomes pos makes it non-const. But who the fuck gives a shit? Sorry. That's why this is not for children. I just make it a reference. That should work. Right. Did I fix it? You'll never know. Until I simply thought, I think it looks fixed. Pretty much looks fixed. Yeah. So somewhere I'm printing this. Let's not do that anymore, and add assert back, and then see that it doesn't fire anymore. Yay! Yeah, they all end in 1, indeed. Because I only work with odd numbers. So every pattern is an odd number. And now I'm going to add the next one, or K4. Damn it, another assertion. Subtract 1. Still a subtract 1 from an a non-zero 0 or more repeat. Why? Why can't it just work? Yeah. Yep, that would do it. Or not. Did I just fix that? Wait a minute, now I'm confused. This is just borrowing from that. I fixed that, didn't I? No, I didn't fix that. Oh, right. Yes, I am. Now I'm getting it. Yeah, this is again split up, and this time not in prune, not in pruning. That's the same error as we saw before. So why exactly is this now happening? The reason it is happening is because this pattern existed. The whole square bracket zeros is weird. Comes from this one maybe. No, don't see it. Yeah, the patterns get larger and larger, and then it gets harder and harder to debug. For a start, I have to print these things on separate lines. And this is totally unreadable, like totally unreadable. This is printing of the list, which is defined as a vector of KClass, which I thought I had a, well, I do have that. Operator for, yeah, defined. Got a lot of those. I think there it is. And I'm not printing new lines here. Why not? Nothing to do with the size, man. Just print it on new lines. So I want to print. I don't even have a separator anymore. New line, indented. Yeah, well, whatever. Just print a comma. Or I can change my separator. Okay, I go back. Choose separator. Definitely better to print these repeated patterns in base 3, I think. Well, this is already too large to print or not in the print 0b. Oh, it's printed. But how to print it in base 3? No idea. No idea. I must say that's also not really. No, it's just as random. That's not as random. That is very not random. Nah, it's just nonsense. It's just a repeat of 3. So this was repeated 3 times. So you see that back, of course, in base 4. In fact, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could use base. It's of course 9, I would say. The number of digits is power of 3. So So I want to do that, and then I have a huge base. What is the base of that? Base of base 27, right? We can do that, base 27. Not really. I want something that repeats. Base 9. Nope. Nah, stupid. I meant, of course, 12 or something then. No. I don't know. 4 times, let's try octal. That repeats. Yeah, hexadecimal. It's got to be binary something. And here the repeat of 3 is already gone. So the best we can do is octal. Then you still see a repeat of 3. Yeah, and then especially for post bunny base 7. Random shit. Yeah. Yeah, okay, what are we going to do? Are we going to abandon this project at this point? Because we know, we have seen it on YouTube, the other YouTube from Veritasium. Yeah, this is the most dangerous mathematical problem in the world. Supposedly used in the Cold War to slow down the scientific progress of the USA. So I should stop wasting my time with it. It's going nowhere anyway. It's an interesting problem, but damn, I have to put it out of my head. Put it out of my head. Just constant crashes or assertions. Why? Why cannot you just finish the last thing so I can print K a lot and then still see nothing? This is a nice pattern. Yeah, they're trying to consume me. Nah, I don't think that was really the case. But it's a funny fact. Okay, well, just one more attempt here. It's a bit, it's maybe not enough 3 numbers, but on the other hand, they are large numbers, right? So I'm gonna print this value. Ah, wait, it was a repeat. It's just a repeat. We're never going to be able to find that. Probably easier to find it with mathematics. With the logic behind it. Where does this number come from? It is a repeat of what I just copied, so this here. Which means it came from definitely is a often occurring thing. It came from here, all the way from here. When is the first time that thing occurred, that pattern? It's got to be significant. What are you doing? Is it still calculating my first hit? What? Wait. Let's try that again. Nope. Oh, that's already a lot of output. A lot of output. Okay, here I'm starting it, and then the first time that pattern occurs is here. And a division of 3 of the repeat of that. Yeah, right. Yeah, of course. Of course. And 7 is the division of 3 of 21, which in itself is the repeat of 0, 1, which is division of 3, which is 4 minus 1. So we might as well stop there. So we're going to start with 3 and 2 bits. Yes. Let me write a quick program. We have the number 3, which is 2 bits. Then I'm going to call a function that converts this as follows. N is my function. And B is just triples. I know that, so I don't have to return that. And then we print the results. And the function is, yeah, I really want that last bit as well. Come on, in type. F in type. N, comma, int, the number of bits. Oh, that's nonsense. That is nonsense. I just want to do, I just want to calculate n becomes n shifts left 2 times b plus n shifted b plus n. Insane laughter. And divided by 3, which is always possible. No return n. So drum ruffle. There's going to print 21. No. Damn, really? What did I do wrong? N is 3, B is 2. 2 times this is 4, plus that, plus that, plus that. It's just 1, 1, 1, 1, 1, divided by 3 is 21. Definitely 21. Why is it printing 513? Impossible. Impossible. Possible. I need a debugger for this, means that I have to go to bed. Break main, run. Next step. Print N, 3, print B, 2, next, print N. Oh, I think it's a matter of, it's just a matter of, it's a usual matter of precedence of this a bloody shift. There, get all the parentheses you want. Nah, that's nonsense. These parentheses should not be necessary. $85, that's still not 21. That's what I should. That's what I want to produce here. Yes, thank you very much. Break main, run. Next. Oh. N is 3, yes. And B is 2. So if I do this, then I get 1, 1, 1, 1, well, it must be 15. Print N, 15, yes. And then, oh, and then I'm shifting the same N again. Cry. Yeah, okay, so this was a better idea, but I have to add a load of parentheses around it. There. Are you now happy? Are you now happy? 21. So it's maybe clear now that I'm smarter than a computer. I knew that it was 21 way long before my program knew it. Okay, then, my friend, we're going to do that again in a little loop. Very little loop. Now that goes up fast, very fast. Did I see this number before? I still have this pattern here, which we can print. Print 0B binary. That is 9709. Why is it printing 21? Oh, right. I need to divide by 3 before I do that. Oh, I'm an idiot again, as usual. Let's see what gives now. Prints the same numbers. Now let's start with the pattern. What if I start with 1? Now I get my number. Okay, that's better. I could repeat it 3 times, which is what actually occurs in the pattern, but I think that the number database is better at looking up smaller numbers. Apart from that, I'm not even being able to calculate the next number after this one. That's probably already an overflow. Okay, we have 3 numbers. Great. I don't think the number database has any clue what this is. Integer. What was it? Number database? It is something called something else, but yeah, encyclopedia. I think 3 numbers are 1 not enough. It's going to claim that it is not enough. Did I just close the thing? Really? I don't know. Pressing Control Top instead of Alt Top. Okay, so 9709. Oh my God! It knows. That's great. That's really great. Yeah, of course, this number is 2 to the power 5 of 3 to the power n minus 1 divided by 3 to the power n. That's really great. That is really great. So, comments. The next term is too large to display. Funny shit. So that means that we can print K3, K4, K5 maybe, but after that it becomes ridiculously large. So it's very quickly not very interesting anymore. But on the other hand, I can replace it with this formula and then be done with it. We don't even have to print these long numbers. It's just that bit pattern. Repeat it as often as you want. What, you don't want to repeat 1 billion bits? Well, don't. But don't tell me I didn't tell you. Now you can add a comment now here. It also occurs in the Collatz conjecture numbers. Yeah, I just an obvious coincidence, I suppose. Now I need, in order to check this number, what you want to check, of course, you fill in only 3 numbers, and if the next number is correct, then I believe it. But then we need a big number library to calculate it. But we have that. We have that right at our disposal. So why not? ZZ. And I think that these things can be done with ZZs. And ZZ. And we're done. Well, except then that I need to include a header. I guess that one of these files, I think it's still in patterns, that we have to include that and namespace NTL, and then it should work. Too large to be displayed. It's a one tiny line in a big font. But anyway, that number looks very much like it starts with 24 as well. Okay, I'll just copy it from here, I guess. Paste it here. Is it the same number? Oh, totally the same number. Wait. 8, 1, 12, 13, 18, 14, 25, 6, 9, 2, 7, 6. Yeah, it's the same number, so it's probably correct, right? So that's the next number. No, okay. So these numbers, which we now have in formula form, are being repeated all the time. In other words, I don't even have to print them anymore. I can just leave them out. If you ask me. I'm not interested in those numbers. But what I am interested in is what if I do not repeat any of them, then you get other numbers, which are also big, but still, you know, a concatenation between certain things. But then you get stuff like this, because suddenly one of the huge patterns was needed to borrow from, apparently, or something like that. Ooh. Wait, this is weird. This thing doesn't look like it was borrowed from at all. Well, it was. It's a part of that thing, but not entirely. Yeah, oh, it's a repeat of 2. That's why. Yep. So this is a repeat of 3, and then we have to repeat it 2 more in order to get the modulo correct, so that we can divide it by 3. So that way, these huge numbers sneak into our constant numbers. But probably in a predictive way, right? I mean, okay, they're huge, but I mean, I just select something, and bang, we have it. So it doesn't seem that difficult. This is definitely a pattern. There's a pattern here. Yeah, no, I mean, this stuff that is left over here also appears absolutely everywhere. I can't shake the feeling that it should be possible to write this in formula for it. A complete formula. Ish. Oh, yeah. Sort of. A formula that would be solvable, as it were. That would be nice. I suppose that the next step is that I print not the binary anymore, but I print repeated patterns. So this whole thing is called A, or AAA, and then A is the repeated pattern, and then I replace everything that is the same pattern also with an A, and then you get suddenly something that is very small. And then all those patterns, A, B, and C, we have a formula for. In other words, all these numbers. I can generate these numbers, convert them to binary, and then when one of these numbers occur, I replace them with A, B, C, D, etc. And that should suddenly give a super clear overview of what's going on at this level, and maybe even a few more down the line. The only thing that worries me is that at some point I'm going to have to borrow from that pattern, and as soon as I subtract 1 from it, it's not recognizable anymore. So then I have to write like A minus 1. And that might escalate in a certain way at some point, but then again, it might not. It might also be beautiful and catchable with the formula. Anyway, what we were doing was trying to print something, and it crashed again. So I did not get any further than printing expand S. The last one doesn't work yet. Post Bunny, you said you had to go in 10 minutes. That was a while ago. So this is K3. Bye. I should go to, but I'm still staring at my patterns. So what happened, this is repeated 3 times as bit pattern. 0, 1, 0, 1, 0, 1, then it's 21 divided by 3 is 7. Then you get this one. And then that is repeated 3 times and divided by 3, and then you get this. And then that is repeated 3 times and divided by 3, and then you get the next number. And that is just that's just this this formula, this series here. And then what is in between those numbers? Too much output. Should reduce the amount of debug output. This is K2. Because I missed K3 somewhere. Nope, that's K3. Whoa, that's quick expansion. Growing a little bit fast. Yes, this is K2. Yeah, so these patterns in between here, they are simply 1/3 of these two patterns, and these two patterns are 1 less than these two patterns, which are respectively a repeat of 1 and a repeat of 2. What is repeated 3 times here. And this 0, 1 is really this one here. So the next one is a 7. Then we have 7 and repeated once and twice, minus 1 divided by 3. Or not. So let's look at K3. So let's see if that is correct. It's not entirely 7. It's 7 with 2 zeros. So the 7 is repeated once and the 7 is repeated twice, but there is also 2 zeros here. So it's more like than 7 times 4 and then minus 1. Or not. No, there is not even a minus 1 here. Well, this is already multiplied by power of 4. That thing is in between. Yeah, so even after subtracting 1, it's still there. Is that divisible by 3? I've got the feeling that something is wrong. I don't think my division by 3 is correct. It's not correct. Nope. It's not correct. I forgot to do my underflow carries. So this division by 3 should have altered this pattern. Yeah, well, I have to quit this project. It's just the whole Collatz Conjecture thing is not what I want to do. I haven't given up, as in, you know, I see still possibilities here. But we all know that certain people have spent 10 years on it, real mathematicians. They just still haven't proved it. So it's a bottomless pit. I think I'm gonna stop. It was fun for during Christmas, but I already did it 3 days now. I should go back to don't even have my window open. This is GDB. Just can close that, I think. Vulkan, yes. Let's continue with this tomorrow. At least I have better debugging tools then, again, available. Good night, peoples. Maybe I'll see you tomorrow. Thank you for keeping me